Another separate topic of process synchronization and critical section is the topic called semaphore. Now, what is a semaphore and why we required? Now, till now, what we have seen different solutions. We have seen some hard software solution, which was Peterson solution, and there is a restriction of two process that solution is only for two process. Now, in the hardware solution, we have seen test and wait, which is a complete solution, but again, we have another solution called swap instruction, which is not a complete solution, which actually is having mutual exclusion but doesn't have the progress as well as the bounded weight. And that was again a hardware solution. Now, do we have any provision which will make it as a software solution for n number of processes? Means more than two processes. So the answer is yes, we have a solution which is called semaphore, and semaphore is used for the critical section problem, and it is applicable for more than two processes. Means n number of processes we can use here, and we can use it for the critical section, and for that we use actually semaphore concept. Now let's understand what do we mean by semaphore. Now semaphore is an integer variable, so you can see that semaphore is an integer variable that apart from initialization is accepted only through two standard atomic operation. Now what will happen is semaphore will be initialized with some value. So a semaphore generally we represent with the variable s for semaphore. You can take a, you can take b, you can take x, y, z, whatever variable you want to take, you can take it. But to understand the variable type, we say it is a, we represent it with a s. So let's say if s is a semaphore, this semaphore could be initialized with any of the value. Let's say it is initialized with 0, initialized with 1, initialized with 2. So any integer we can use. So initialize with 100. So any integer we can take it to initialize it. But which particular operation will access it? So it will be accessed by standard atomic operation, which is called wait and signal. So we have two atomic operation. One is wait, another is a signal. Now again, it is an atomic one, means from here to here, all the instruction will execute once. Means in a one cycle, there is no interrupt. From here to here, the execution will done in a single cycle. No interruption could be allowed. Now let's see what do you mean by wait and what do you mean by signal. So once a process want to execute the critical section, it has to call the wait function or the wait operation. And once the process will get out from the critical section, it will call the signal function. Very simple, right? So in this typical program, here in this particular box we have critical section. Before critical section we have entry section, and after critical section we have exit section. So assume that in the entry section we can use wait, or we can call the wait function or the wait operation, and in the exit section we can call the signal operation. Okay, now about that we'll see shortly. Before that, let's try to understand wait and signal. Now first you understand signal function. So signal function will take s. What is s? S is an integer, right? Semaphore integer or the semaphore variable. So s value will put into the signal, and whatever the S value is, will make it plus 1. So it will just increment the S value to 1 or the semaphore to 1. Now what weight will do? Weight will also take S value, but it will be doing the opposite of it. It is incrementing, it is decrementing. It is incrementing S value, it is decrementing S value. Now this S value will be decremented here, but before that we have a condition to dissatisfied. If condition is satisfied, will be in the loop because here we have a semicolon. So if condition is satisfied, what is the condition? Condition is if S is less than 0 or not. Or you can say S is less than or equal to. Less than or equal to 0 or not. If S is less than or equal to 0, then what will happen? Condition is satisfied and will be in the loop. If S is not less than or equal to 0, then this particular instruction will be executing, which is S equal to S minus 1. So let's assume that the value of S is 1. Let's assume that. And there is a process P1, right? So as I told you, how your instruction will look like. So here, this is the instruction with the while loop. Let's make it to the semaphore. That how if we'll use the semaphore, then how it look like. So we have the critical section, but instead of entry section, we'll call wait with the value of S, and after that we'll call signal with the value of S, and then reminder section is going to be executed, right? So if P1 is there and P1 want to execute to the critical section, so the first what it will have to do, P1 has to call the wait function because this is the entry, and wait it will call with S. So it will call a wait with S. What is S value? S value we have taken as 1. Now once it will do that, wait 1, S is 1. 1 is less than equal to 0. Is it satisfied? No, it is not satisfied. Then we'll go out of the loop and we'll execute this, which is S equal to S minus 1. So what is the value right now? S value was 1. It will become 1 minus 1. It will become 0. So right now, what is the S value? The S value is 0. Now if the S value is 0, it will be, after that, it will go to the critical section. Once a process in a critical section, it will execute the critical section. Once it is getting out, it will call the signal. What is signal? Signal is again S, right? So we'll call the signal with the value S. And what is the value in S is right now 0. We'll assign 0 here as S, and we'll do S equal to S minus S plus 1. So the S value will become 0 plus 1, it will be 1. Getting it? And then let's say P2 is you want to execute, then again P2 also has to do this. It has to wait, and then after that, once this condition is satisfied in the wait, it will be called S equal to S minus 1. Then it will become, S will become 0. Then critical section is going to be executed. Once it will coming out of the critical section, signal is going to call. So signal is going to call with S value. What is the S value? S value is 0. Then after that, because it will not have to check any condition, it will just increment S by 1. It will just increment S by 1. In that way, then P3 will come, or maybe P4 will come, or maybe up to Pn, right? So this is how your wait and signal is going to use. Now, so this is the wait and signal, and it is the concept of semaphore. Now let's talk about the application of semaphore. We have seen that what is the usefulness of this, what is wait is signal, right? Now let's talk about the application of semaphore. So mainly there are three application of semaphore. So the first application is called critical section solution, means we can have a critical section solution here. It means that the critical section will be used with the characteristic mutual exclusion, progress, and bounded weight. So the critical section would be achieved. Second, order of execution of process. This is a second application. Means with the help of the semaphore, we can actually order the execution of the process. Let's say we have process P1 to Pn. So which process will come execute first, and after that which process will execute, after that which process will execute, after that which process will execute. All these things means the order of the execution of the processes which are available could be done using the semaphore. Next application of the semaphore are called resource management. It means that if we have more number of resources, and based on the request to that resources, how we can manage it. It means that how we can assign the process to the resources, what the process is required. Let's say a process is required to printer to print, or a process is required a scanner, or a process is required the CPU, or a process is required something else, other resources. So how we can allot it. So the management of the resources could also be done using the semaphore. So mainly semaphore has three main application. First application is critical section solution, means it could achieve mutual exclusion, progress, and band or bounded weight. Order of execution will be achieved here with the help of semaphore, as well as resource will be managed very easily with the help of semaphore. Okay. So the first solution is called critical section solution. Now, the critical section solution, we all know that what is a critical section. So critical section is nothing but a part in the code. This is nothing but the part of the code which is a shared resource between two or more processes. So assume that this particular critical resources are here, and we have something n number of processes. We have P1, P2, P3 up to n number of processes. And so what is the solution? The semaphore solution is this. Means before the critical section, you have to call wait function with the value of s, and after critical section, you have to call signal function or the signal method with s. Okay. Wait, you already know. This is the definition of wait, and this is the definition of signal. So here, the definition of wait is here, and the definition of signal is here, right? So this is the definition of wait, and this is the definition of signal that we can use. So this is how your, let's say we have a while loop. In between, these process is going to execute. Let's say here we have the reminder section, and let's say this is for process pi, means for all the process this is the code. Let's talk about three most important criteria. First is the mutual exclusion, second is progress, and the last one is the bounded weight. Let's see one by one. So the first one is the mutual exclusion. Mutual exclusion means if one process is there in the critical section, so will not allow other process to execute into the critical section. Let's assume that P1 is already there in the critical section. So for that, we'll take from the very beginning. So let's assume that semaphore has a value 1. Okay. And let's say P1 want to execute into the critical section. So if P1 want to execute, it has to call the wait function first. So what is wait function? Wait function is having a loop. It says that S value should be less than or equal to 0. If yes, it will be in the loop, otherwise it will go out of the loop. So P1 says that, or we'll find out that S value is 0 or less than 0 or not. So it is 1 actually. If it is 1, this is not satisfied, then it will go to the S equal to S minus 1. So what is the S value right now? So right now, the S value will be 0. Yes? Because wait has been executed. Now once the wait will be executed with S value as 1, then what we do is S equal to S minus 1 we have done, and then because wait function is already done, it will go to the critical section. Let's say P1 is already there in the critical section and P2 come into the picture and P2 want to execute into the critical section. Can we allow? So you see P2 will also execute the same thing. First it will execute the wait function. What is wait? Wait S. What is wait S here? S value is 0. So 0 will come here. While 0 is less than equal to 0, yes, because 0 is less than equal to 0, that condition satisfied. Then it will be in a loop. So P2 will be in a loop and it will never come out one come till S value is more than 0. So because S value will become more than 0 if P1 will satisfy all its execution, means it will satisfy this signal, right? So once it will satisfy the signal, then only P1 will get a chance, P2 will get a chance to become S value is greater than 0. Because P1 is already in the critical section, P2 will not allow into the critical section. So mutual exclusion exists. Next is the progress. Progress is that if an interested process want to join the critical section, it can join it if critical section is free. So if a process want to go to the critical section, it can go. Now you assume that process P1 has executed the critical section going out, and then this value will be restored to 1, and then which process can go? So any of the process can go, there is no problem. Let's say P1 is going, so P1 can also can go here and execute the wait and then signal. Can P2 go? Yes, P2 also can go because P2 critical section is free and nobody is stopping that. Or P3 can go, or P4. So any of the process can go here. There is no problem. So any of the process can go into the critical section and the progress achieved. Let's see the bounded wait achieved or not. Let's say P1 is going into the critical section and again P1 will get the chance to go to the critical section. But P2 is waiting to go into the critical section. Now here we doesn't have any provision which will tell us that P2 is waiting for the critical section and we can give more priority to P2 because it is waiting for a longer period of time. That provision is not at all here. Because in this particular code there is just wait. In the wait, what we do is we just see whether the condition is satisfied or not. If it is satisfied, we'll execute the code and we'll go to the critical section. Once the critical section work is done, we'll go out of the critical section and we'll call the signal. Signal will just increase the value of the semaphore. So here the semaphore is just like a lock. The lock value will not be less than or equal to 0. If it is, the process has to wait. If the S value is greater than 0, then the process will go and execute the critical section. Very easy. So here in this particular example or in this particular solution of semaphore, the bounded weight doesn't exist, but two essential criteria satisfying, which is a mutual exclusion and progress. So we are going to say that the semaphore is a solution for the critical section.